Ceramic Science presents How to Find the Mass of Molecules. To begin, we need to look at the periodic table of chemical elements. To help us find an element on the table, we can use the atomic number. For instance, if we know the atomic number of hydrogen is 1, then we know that hydrogen is in the upper left corner of the periodic table. If the atomic number is 2, we look to the right. If the atomic number is 3, start on the next line. Atomic numbers 4, 5, 6, 7, 8, 9, 10, 11, etc. continue in this same manner. If we want to find germanium with atomic number 32, we just find the 32nd element on the table. Chlorine has atomic number 17, so it is the 17th element on the table. The atomic symbol is in the middle of each box on the periodic table. The atomic symbol for chlorine is capital C, lowercase l. Note that capitalization matters since capital C, capital I means carbon and iodine instead of chlorine. All atomic symbols start with a capital letter and any other letters are lowercase. Let's take a closer look at the box for chlorine. The atomic symbol is capital C, lowercase l. The atomic number is in the upper left-hand corner of the box, and for chlorine the atomic number is 17. The atomic mass can be found in the upper right-hand corner of the box, and for chlorine, the atomic mass is 35.453. This means that one atom of chlorine has a mass of 35.453 AMU. AMU stands for atomic mass unit and is the unit that is usually used to measure atomic mass. This unit is so small that we will usually work with moles of a material instead of a single atom. 1 mole of anything is 6.022 times 10 to the 23rd of that thing. So 1 mole of chlorine is 6.022 times 10 to the 23rd chlorine atoms. That is a lot of chlorine atoms. Moles are useful because they allow us to translate from atomic mass units to grams. 1 chlorine atom weighs 35.453 AMU, but 1 mole of chlorine weighs 35.453 grams. To find the mass of 2 moles of chlorine, first find the mass of 1 mole of chlorine, then multiply by 2. Similarly, to find the mass of 3 moles of chlorine, multiply the mass of 1 mole of chlorine by 3. This works for any number of moles, even non-integers. To find the mass of 0.7 moles of chlorine, find the mass of 1 mole of chlorine, then multiply that by 0.7. Now we need to understand what a molecule is. When multiple atoms bond together, they form a new molecule. As an example, if 2 hydrogen atoms bond to 1 oxygen atom, they form the molecule we call water. To express this chemically, we use a chemical formula. The chemical formula for water is capital H subscript 2 capital O. This is usually stated as H2O. Once we know the chemical formula for a molecule, we can calculate that molecule's weight. As an example, let's look at capital F lowercase e subscript 2 capital O subscript 3, or Fe2O3. How many different elements are in this molecule? To find out, we can count the capital letters. In this case, the capital letters are F and O, so there are 2 different elements in the molecule. How many atoms are in the molecule? Now we need to add up all the subscripted numbers. If there are any atomic symbols that don't have a subscript, then we count that as 1. In this case, we have 2 Fe's and 3 O's, so we have a total of 5 atoms in this molecule. To find the mass, first find the atomic mass of each atom. List the atoms Fe and O. Now look in the periodic table at Fe to find that iron has a mass of 55.845. Next, the box for O shows that oxygen has a mass of 15.999. So what is the mass of one Fe2O3 molecule? Looking at the chemical formula, we see there are 2 Fe's and 3 O's. The 2 Fe's have an atomic mass of 55.845 and 3 O's have a mass of 15.999. Just multiply and add to get a total mass of 159.687. But to give that number any meaning, we need to know the unit. Since we are talking about a single molecule, the unit will be AMU. What does 1 mole of Fe2O3 weigh? Just copy the mass of one molecule and replace the unit with grams. Let's look at another example. Na2CO3. We need a little more space. To find the mass, first list the atoms. Remember, look for capital letters at the start of each atomic symbol. Thus the atoms are Na, C, and O. Now we need to find the atomic mass of each atom. Na is sodium. According to the periodic table, sodium has a mass of 22.990. Next, carbon has a mass of 12.011. Finally, oxygen has a mass of 15.999. What is the mass of one Na2CO3 molecule? Well, we have two Nas, one C, and three Os. Na has an atomic mass of 22.990, C has an atomic mass of 12.001, and O has an atomic mass of 15.999. Multiplying and adding gives a mass of 105.978. Since this is for one molecule, the unit is AMU. Thus, the mass of 1 mole of Na2CO3 is 105.978 grams. To find the mass of 2 moles, just double the mass of 1 mole to get 211.956 grams. Or to find the mass of 7 moles, multiply the mass of 1 mole by 7 to get 741.846 grams. To recap, to find the mass of a molecule, first find the atomic mass of each atom. Next, multiply the masses by the number of atoms in each molecule. Finally, add these numbers together. If you're talking about a single molecule, then the unit is AMU. If you are talking about moles, then the unit is grams.